page 23, if we're looking at the zeros of a quadratic, okay, zeros of a quadratic function, what are they talking about when they say zeros of a quadratic?
Quadratic function is the one that's like a U shape, right?
Yes, it is the one that's like a U shape. So let me draw a U shape.
Is the where we add the roots.
The roots, good. So zeros, another name for zeros, you're right, is the roots. And this is what a quadratic function looks like. Okay? So they're telling you if the zeros of the quadratic function f, here it is, I drew one, -3 and 5. Like you said, it's the roots. What they're talking about exactly is where they cross the x-axis. Okay? Meaning this one is the what?
3, -3.
And this one is the 5. Okay? It says, what is the equation of the axis of symmetry? Now, from yesterday, what was the axis of symmetry?
Where it met at the vertices, where it was like straight up and down.
Good. Okay? You said where it met at the vertex, and it's straight up and down. So you're talking about this line right here. This line right here would be your axis of symmetry. Okay, but where is it? What does it do to the quadratic?
Split it in half.
Okay. So it's going to split it in half. Okay, so they want to know what's the equation of this. Now, the axis of symmetry is always what letter in front?
Y.
X.
It's always, always, always in the form of x equals and then some number. They're asking you what is that number right now. Okay, where is this line again? Where is this line again?
Half.
It's halfway. It's halfway in between -3 and 5. What's halfway in between -3 and 5?
4.
Well, would a 4 right here be halfway in between -3 and 5 if I'm right here?
Oh, negative. Oh.
Ah. Okay, so we have to be in an even amount. So let's count. 1, 2, 3. All right? 1, 2, 3. 4. 4. So if I count in 4 from the right and 4 from the left, what number is this?
2.
Hold on. That little number right there doesn't count. This one right here is a mistake.
2.
Okay. How far in am I? Not 2. I'm in at what?
1.
That's 1. This is the equation of x equals 1. Why? Because if I do this on a real number line, the vertex or axis of symmetry is directly in the middle. Okay, so my graph was a little botched, but 1, 2, 3, 4, 4, 1, 2, 3, 4. They both land me at x equals 1. Okay, so that's halfway. Okay, take a second and read question number 14. What are they asking you for in question number 14? To find the roots / the zeros of the function. They want the roots. Here they wanted axis of symmetry. Now, your roots of your function, where are they when you're looking at a table?
On the in the numbers above and below are the same.
That would be the vertex, if the numbers above and below are the same. I'm looking for the zeros. Give me the correct zeros.
2 0 and 3 0. Well, negative 2 0.
Okay. So, these are the zeros that you're looking for. Again, if you were to go to the back of the Regents exam, you could graph this on graph paper to see which ones truly are. Now, I'm going to sketch this so that you may see it. Okay? Most people would try to pick this 0 as well, and it's not. This 0 is not included when they say roots. If I was to sketch this,
Does the guy start from the x-axis?
it has to be on the x-axis. This function would look like this if you sketched it on graph paper. This is what the function would look like if you took a sheet of graph paper and tried to graph it. It would look just like this. Notice I left this off on purpose.
Why?
Because by the way that the graph looks, it looks like you should connect it straight across when we know it truly dips right here. So there's another point right here
That look like.
that's not given. Okay, it's the point that should be right here where the true vertex should be. They missed and did not give you the true vertex. Remember, the vertex is exactly where it starts to turn around at, and we can't have two of them because they're not flat on the bottom, they're rounded on the bottom. But anyway, continuing, you can clearly see this, again, is where they're talking about where they say roots and zeros. All right, any questions?
Nope.
Now, I'm not even going to teach you guys this because it's not that important. It's not like it's a dire thing. It's going to be on the Regents exam. There's no point of trying to teach you guys everything. I'm just going to try to teach you guys what I can. All right, so I'm going to move to the next page, 24. 24 is all about adding and subtracting, multiplying and dividing polynomials. Okay, so in the first one that's here, what's the key word? Okay, so if I'm looking at this first one right here, the key word is sum, and what do they mean that they want you to do? The key word is sum. That word means to add. And I'm going to add what?
Negative 3x squared minus 7x plus 9 and negative 5x squared plus 6x minus 4.
We will, but which pieces will I add? So if I have, this is my first polynomial, this is my second polynomial, which pieces from the first polynomial will be added to which pieces of the second polynomial? So when we add these, we're looking for what we call like terms.
7x and 6x.
Okay, and then we just have to make sure that we're careful. Like, I'm going to put circles around these things. And if you notice, I'm being very careful in grabbing the what in front of them.
Negative sign.
I'm grabbing the negative sign and or the positive sign. Not necessarily that I need the positive, but I want to make sure of what terms I'm talking about. Those are terms, the pieces inside the bubbles. Okay. So the first bubble, the x has a power of what on it? 2. So which piece does that match over here in the second polynomial?
5x squared.
These two go together. So this negative 3x squared, and what sign will go in the middle?
Plus sign.
A plus sign, because I told you to add them. So plus a negative 5x squared. So this plus sign right here comes from this word sum right here. And then I'm going to continue. So I use this number and I use this number already. I'm going to move to the next one. This negative 7x matches what piece in the second polynomial?
6x.
Positive 6x, yes. So do you ever write positive 6x, or you just write it as 6x?
I write it as 6x.
Because we know it's positive. And again, the plus sign in the middle is from that word sum. All right, I use the negative 7x, I use the 6x, now I have a 9. So 9 plus, because of the word sum, what's the term? This is where I'm going to get kids. It's not 4. It's negative 4.
How can you tell?
See that sign in front of it?
Yeah.
If I did just like that, you guys would read that as a what 4?
Negative.
A negative 4. Now, if it was like this, you would read this as 6x minus 4. But notice how I had circled it. So that becomes independent, becomes all by itself. That's when it turns into a negative sign.
Oh, so like when you separated the terms. Okay.
Yep, when I separated it into terms, you grab the sign, and that would become a negative sign. So now I can go through and simplify this. Okay, now, what will each one of these become?
I'm going to do a laboratory real quick, miss.
Did you say the last one?
Yeah, that's about it.
Okay, so I'm going to do this right in my calculator. Negative 3
Negative 8x.
plus negative 5. I get negative 8. Negative 8 what?
X squared.
Negative 8x squared. Okay, knowing that, which terms are you going to eliminate?
The one with the 4s.
The one with the 4s. That's gone. And that's gone. Now we can do the next one. Negative 7 plus 6 equals what?
13.
So let's test it. Negative 7 plus a 6 is negative 1. So again, make sure you use your calculators to help you with the signs. That's negative 1. So now what has to be my answer?
Number 1.
Has to be number 1. Because this is a negative 1x. And out of these two, this is the only one that has that negative 1x. But yes, this will come out to be a positive 5 if I do 9 plus a negative 4. All right, that's
Negative plus a positive.
a negative plus a positive is sometimes a negative, is sometimes a positive. It depends on which one you have more of. All right, so that's how we add polynomials, by like terms. How do you think I subtract polynomials? Same thing. Now, this is the trickiest one that there ever could be on a Regents exam. Okay. 4x squared plus 7x minus 5 is subtracted from 9x squared minus 2x plus 3. Well, subtracted obviously means you're going to do what? Minus. It means I'm going to have a minus sign in between all of my like terms. So here's your first polynomial. Here's your second polynomial. Okay, so we have 4x squared. We have a positive 7x. We have a negative 5. We have a positive 9x squared. We have a negative 2x. And we have a positive 3. Okay. Now, how am I going to set this up?
Like terms.
Okay, I'm going to use again, I'm going to subtract like terms. So, what subtract what?
4x squared minus 9x squared.
Close. Very close. Now this is how they trick you on the Regents exam because it doesn't say it like that.
So you gotta put the biggest in front.
This word from, that word from tells you that this is really your first polynomial.
Yeah, so
And the other one is your second. It's like telling you, Nasir, take 20 from the 50 I have. So where would he go to first? He'd have to go to my 50, and then he's going to take 20 out of it. So from means the second one is going to go first. So as we're setting this up, that means we're going to do that positive 9x squared minus, because of the word subtracted, the other term 4x squared. So I'll start there. Whoops, I wrote 4. Yeah, it is 4. What is 9 minus 4x squared? 5x squared.
So take away the negative.
Right, and that's how they would try to trick you, Rainisha, is because if you did 4 minus 9, you would get negative 5. And that's how they trick kids on the Regents exam. Okay, so then my second number again. This whole polynomial is your first one based because that word from. From means this second one goes first. So we would start off with negative 2x minus this positive 7x.
Oops.
Okay.
Dang it.
And again, use your calculators to help you. Negative 2 minus 7.
Okay, so that would come out a positive, right?
It actually is going to come out to be a negative.
What?
And only a negative times a negative is a positive.
A negative times negative is a positive.
But here we're not multiplying them, we're subtracting them. So this
On the
becomes,
other side, the one with the lowest number came out to be a positive.
and that was because we were adding them. Here we're subtracting them. It's different rules. That's the reason why I just go with the calculator.
I'll make sure I'm take this down before
Okay, so right now I don't even have to do the last term because the second term is different in both of these. So right now I know it's choice 2. Okay, you guys get the graphing calculators for the Regents exam, so I encourage kids to do as much as they can in the calculator so they don't mess up on basic sign issues. All right. Okay, again, these are all 4 different. This word means what? Multiply. Okay, that means to multiply them. Anybody know how to multiply 2 binomials?
What?
These are called binomials. They're called binomials because they're 2 pieces each.
So what was the other one called?
Polynomials.
Polygon.
Yep. Polynomials means many terms. Like a polygamist who has many wives. So this one's bi because it means 2. Mm-hmm.
Yeah, I know this stuff.
All right, so when we multiply binomials, how many of you guys remember this method? If you were up here in New York, we use this method a lot.
Four square?
The 4 squares. Do you guys remember doing Punnett squares in science class?
Yeah,
Big B's and little B's?
yeah.
We're going to do the same thing. This is like my big B, little b. So big B, little b. And then this would be my big B and my other little b. So big B, little b. Okay. And you guys remember this one was big B, big B? And that's because they got it from up top of the Punnett squares. So this is really m times m because they're asking you to multiply these, right? So what's m times m?
2m?
Not 2m, m squared.
Oh, m squared.
And it would give it away in the multiple choice.
Oh my God.
Okay, so remember this box here would have been big B and little b. So we would do big B, which is our m, times our little b, which is -8. What's m times -8?
Negative 8m.
-8m. This box here, again, would be big B, little b. So we do big B, m, times little b of 3.
3m.
This is 3m. Okay, and then this box was little b, meaning 3 times -8.
And that comes a positive, right?
Nope, not positive. 3 times -24 is, or, oh my goodness, I wrote the answer.
I was about to say you just gave the answer.
3 times -8 is -24.
I thought you said.
So right now, there's a couple I can eliminate. I can eliminate the first one because it has a positive 24. Okay, now I got to figure out which one is the real answer. Okay.
So the first one's out of the question.
Now we have all these boxes that we now can kind of put things together like a puzzle.
So isn't it going to be that 5? Isn't it going to have to be a 5 in it?
Because of this right here, these are like terms like we were doing up here for addition and over here for subtraction. So what we have is
Number 2 is
number 2 is out
out of the question.
of the question because I do have a middle term. So right here, this becomes 3m plus
We should
-8.
cross number 2 out when you cross number 1 out.
Knowing I have middle terms in the boxes that are not canceling. So my middle terms are generally the ones I'm going to collect.
Number 4.
What does this become?
-5.
This becomes
So
-5.
cross out 4 because it is 3.
Oh my God.
Yes,
It is
I
3.
gotta put my
Shut
steps
up.
forward. I'm
Shut up.
just saying. Tight.
Shut up.
All right, let's take a look at the last one on this page, and then I'll allow you guys to try some on your own of all 4 of these.
All 4.
Yeah, an addition, subtraction, multiplication. And now this represents what?
Division.
This represents division. So this right here means we're dividing. Okay, anybody want to take a reasonable, logical guess on what answer they think it is?
I say it's 1.
Okay, reason?
Because it's divided by 10. And it's like 50 divided by 10 is 5.
Okay, so 50 divided by 10 was 5, okay.
And 10 divided by 10 is 1.
I said.
10 divided by 10 is 1, which is the last term.
Yeah, that's what I said.
It is 1. Because basically what you're doing is You're taking each one of these terms and dividing it by the bottom. So you really get 50x to the third divided by 10x, negative 60x squared divided by 10x, and 10x divided by 10x. Well, like you said, 10 divided by 10 is a 1. So is x divided by x. X divided by x still gives you 1. They kind of cancel out. So, yep. And also you subtract their powers.
Yeah, the power.
3 minus 1 gave you that 2. 2 minus this 1 gave you this single x. What happens when you do a 1 minus 1? This becomes 0, which means you have 0 x's. There should be no x's in the last term at all. So that would have gotten rid of 2 and 3. But we still need to hold it with the plus 1. It's not gone completely. 10 divided by 10 is 1, so you can't get rid of it. We could eliminate number 4.
Well, let me just write this down real quick.
So now the rest of them that are on this page, they can combine some of the other stuff that we have learned, like such as distributive property. We could need the box method. We could need a bunch of different things that we have already learned. So I'm going to allow you guys to try all the rest of page 24. Okay, which is only 3 problems. So I'm going to let you guys attempt those ones.